Hello and welcome to the NE Engineering blog. Today I'm talking about a bit of an update to me and one of my upcoming projects. And a few of you already know this, but I've actually gone part-time at work to concentrate more on the robotics side of things. And this channel and my blog and all the rest will be a big part of that. So I've got a few ideas as to for projects for this first phase, as I'm calling it, because I love the Avengers and all the rest of it. So, you know, phases of the MCU, if it's good enough for them, it's good enough for me. And the idea is that this first phase is going to be a big learning experience for me, if nothing else, and also I hope a way for others to kind of follow along at home to a certain degree. So if you're interested, I'll show you the things I'm building, how to build them, and also that you can build them. I'm aiming to build 3 robots in this first phase. How long that takes, who knows? But the plan is that there'll be NE-1, which will be the redux of the old Roomba project. There will be NE-5, which will be a more sensible or better designed version of my PyWars robot, McFeagle Prime. So that'll be closer to the original design for Johnny 5, and also easier to print, easier to just basically work with, because the CAD files became a nightmare. I was very much learning to use Fusion as I went, so all of my mistakes are in there, and it's just hellish. So those files aren't really easy to share. And there will be Anywhere. So I like the puns, obviously. Anyone who's met me for more than a few minutes should know that. But Anywhere is basically the luggage, for those who've been following on. So the luggage was originally a skid steer robot, skid steer rideable version of the luggage from Pratchett's Discworld, and that was for hacky races. And the idea was I'd be able to race it. It turned out to be too much of a death trap, and it would be outside a bunch of the rules. And I'm one of the organisers, so I can't really break them. So it then became just something I was going to ride around for a laugh. The design again was kind of very ad hoc and terrible, which is why it's never really happened. But now it kind of went from rideable luggage to rideable luggage that's also going to be remote controllable to actually let's make it a robot that I can ride. So the NE-1 will be the small rover that can be used indoors and outdoors to a certain degree. Anyone can play around with it, and it'll be off-the-shelf components that are as cheap as I can find them, so that there's the lowest cost, but there's fewer borders to entry. I can't think of the right words. Originally, the idea for that was going to be based around Bumblebee, my old Roomba. So that Roomba is an original Roomba from 2002. I was given it on the proviso that it's broken, and if I can fix it, I can keep it. And it turned out it just needed a new battery. And yeah, I got a new battery. It ran for years, and there's a whole slew of videos of me reverse engineering that on one of my other playlists. The idea was that you can buy these for quite cheap on eBay, and if I could reverse engineer it, which I've mostly done, then anyone could buy one of these, hack into it, and get it working. And I realized that I've been fighting this for such a long time that I've just about got everything working, but there's lots of quirks here and there, and it's been a sticking point for me for a long time. And somebody who's new, who I'm wanting to, get into the hobby, it'll be a nightmare for them. So it was just a bad idea built on a bad idea. So slight change of plan. So instead, I got one of the Rover 5 chassis from Cool Components, and there's a few variations of these around. This one was 45 quid, and it's actually 4-wheel drive, so it's got 4 gear motors around the edge, and it's also got an encoder on each motor. These are also quadrature encoders, so that means that not only will it let you detect how fast it's spinning, but there's 2 sensors offset, so you can actually get the direction as well, because obviously you'll let pop-om, pop-om, or pop-om, pop-om, and that's how encoders work, so they go pop-om. So that'll be very good for being able to track how far the robot's moving and how fast it's moving, and if you're doing, and a few other things which I'll mention in a second. So this is 45 quid, and not only does it have the motors, the encoders, the chassis itself, these tracks which are actually adjustable, it actually includes a battery holder, so it actually slots in between there and it'll hold four AAAs. This runs at about 7.2 volts, so again the batteries are going to be off the shelf as well. I've got a whole bunch of 18650s for another project that are now going spare, that I'm going to make a little pack for this, so that'll be a bit more custom, but you'll be able to use the original pack or this if you want to build your own. So it's going to be a little feature that, you know, those who are able to make batteries can, and those who can't can still use that. So this will be the base chassis for NE-1, and to power that, I'm going to be using a Teensy 4.1. Now this is pretty much overkill. These actually run at 600 megahertz. You can even overclock them if you put cooling on them and all sorts of nonsense. Now that is overkill, but they're 20 quid, I think. They've got an SD card reader on board, so you can either use that for logging, or if you want to put a CSV file on there with waypoints that it follows or something along those lines, you can do that. If you wire it up to a button battery, it's actually got a real-time clock on board as well, which is very useful if you want to do things at specific times or to have more detailed logging. And most importantly, every digital pin on this board is interrupt capable. So what that means is, for the encoders, rather than saying is it high, is it low, and so on and so forth, you can basically say, right, I'm attaching this function to a pin, and that function is a bit of code that when the state of the pin changes, that code will run. So rather than having to constantly poll, you can have it do it for you, so you don't have to hope that you're catching one as your loop goes around. It's just gonna grab it as it goes. And that's something that I found a big limitation when I was working on the Roomba. I was using an Arduino Mega, and that has I think 6 interrupt pins on it, but 2 are already used by the serial port and another 2 are used by I2C, and I needed that for something else, so it was basically a no-go. And because these are quadrature encoders and there's 4 of them, I actually need 8 pins in total. So yeah, this just is just makes perfect sense. For the motor controllers, I'll be using these tiny little things, and I honestly bought a bag of 10 of these long enough ago. I can't actually remember the name, but once I get into the project, I'll give you the information for these. They're a couple of quid each off eBay. So that's the goal, is that for 100 quid you can build, thereabouts 100 quid, something that's incredibly capable that you can build on for the future. So that's the microcontroller and the motor controllers. The other thing is actual control. So for that, I'll be using a Bluetooth module. So you can get these little Bluetooth modules that I can't find at the minute, that you can plug into the board. It hooks straight into one of the serial ports on there, and any serial data that goes into it basically gets transferred straight across Bluetooth. And the idea is that it's completely transparent, so you don't have to worry about setting it up in any meaningful way. You just have to plug into the board and then pair with it from your computer or from your Pi or your phone or however you want to do this, and you'll be able to communicate with it. The benefit there is that you can, for one thing, if you put it into the right ports, you should be able to program it over Bluetooth, which makes it a bit easier, rather than having to plug a USB cable in and unplug it and so on and so forth. You can program it over and debug it over the air, but it also gives us a lot of opportunities further down the road. So one of the other benefits with this chassis is it's chunky, if nothing else, and you'll be able to expand upon it. So in the first instance, it'll be driving around, finding out, getting the speed, moving certain distances by counting the number of times the wheels turn, so you can get the distance traveled, and that'll be the basics. You know, opening up a little terminal, typing in WASD, for example, so you can drive it around using a keyboard. Now, when things progress, because we're using Serial, it'll actually give us access to ROS, the robot operating system. So that's something else I'm going into a lot of detail learning at the minute. And if you're a follower of James Britton's channel, he's already had a head start. He can talk a bunch there about what ROS is and how it works. And the idea will be that if you want to go down one route and do the more basic stuff with just Bluetooth and controlling it that way, which is still incredibly versatile, and if you go down the Bluetooth route, you could also mount a Raspberry Pi on the board, at which point you can just take the module off and plug straight across, and you wouldn't really have to change anything. But it's also, if you put different code on there, then use the ROS serial, for example, and it'll be able to transfer and receive commands straight to and from the robot operating system running on a different machine. So you'll be able to very quickly play around with something, but also have the versatility to expand upon it on the future and integrate it with ROS when you're ready to move on further. And yeah, that's another thing, is this will be a cheap robot for people who want to play with ROS to build and to try. And you know, once the basics are run, the usual distance sensors will be installed around the edge, and to a certain degree it's essentially going to be very similar to McFeagle Prime. It's got tracks, it's got uses Serial to communicate with a Teensy, and therefore a lot of what I learned from this will be instantly applicable over with the other robot as well. So that's the plan for NE-1, and yeah, stay tuned for more information, really. In the description I've got a link to my Patreon page as well, which I created, obviously dropping down from 2 free days a week at work. Yeah, if you're able to literally put £1 in the pot every month, it'll help. You know, it'll all eventually build up, which is very useful. And if not, everything's still going to be free. You know, times are hard, to say the least, and yeah, I want as many people to be able to see this as possible. So if you support on Patreon, you'll get depending on what level, you'll get early access, your name in the credits. But otherwise, if you wait a couple of days, then you'll get access to the same stuff. There'll just be early access for patrons of certain levels. It's just to give a bit of incentive. So yeah, that's it really. That's the big plan for the first of the robots, and over the next week I'll get the robot actually moving. So next week should be more of an update on how it actually works and where we're going from there. So stay tuned for more. Hope that you find this interesting, and bye for now.